This is regarding the nuclear fusion technologies which has created a milestone such as creating a sun in a lab. So what is the significance of the recent achievements made in thermal nuclear fusion technologies? Imagine creating an artificial sun on Earth that can produce energy from the same process that gives us starlight and sunshine. Two recent achievements have taken us a step closer to this dream. China's experimental advanced superconducting EAST, that is tokamak sustained plasma at 70 million degrees Celsius for about 1056 seconds in January 2022. In February 2022, the joint European Torus, that is JET fusion experiment in Oxford, that is UK, produced around 59 megajoule of energy from thermonuclear fusion. So these are the dress rehearsals for the upcoming International Thermonuclear Experimental Reactor, that is ITER, a global experiment to generate around 500 megawatt of power by fusing hydrogen atoms into helium atoms by 2035. So what is thermonuclear fusion? In a thermonuclear fusion reaction, lighter atoms like those of hydrogen fuse into produce a straight heavier atoms like that of helium. The whole is a grade that sums. Sometimes the sums are greater than the whole. The mass of one hydrogen atom is around 1 lakh times atomic mass unit, that is AMU. When 4 hydrogen atoms are combined, it transmutes into a helium atom. The sum of a mass of 4 hydrogen atoms is around 4 lakh AMU, while the mass of one helium atom is around 4 lakh AMU. As we know, matter is neither created nor destroyed according to the energy conservation principle. So by the Einstein formula, the famous formula E equal to mc square, if you fuse 4 grams of hydrogen into helium, about 0.0028 grams of mass would be converted to 2.6 into 10 power 11 joules with that of energy. So we can see the light of 60 watt light bulb for over 100 years. Yes, exactly 100 years. 600 million tons of hydrogen are fused every second in the sun, producing 596 millions of helium. So if 1000 of the gram of mass can create energy to power 60 watt bulb of 100 years, imagine the amount of energy remaining 4 million tons of hydrogen unleashed every second by the sun. So what's the history of efforts to achieve nuclear fusion? On March 24, 1951, the Argentinian president Juan Persson stunned the world by announcing the success of periodic helium led by Nazi scientist Ronald Richard to harness the energy from the fusion. Now knowing that he had been tricked, he went on to say that the invention would bring a greatness which today we cannot imagine. People went on to believe that with the technology at the hand and two superpowers, the US and USSR, striving to one-up each other in the technological process, building the thermonuclear bomb were feasible by harnessing energy from the fusion process. But this also turned out to be a science fiction. While the world wondered how a rural, backward Argentina could put together the technology, it soon became clear that the Richard had pulled and fast one. This, in a political precarious position, Perrin had also fallen for it. So both now USSR and US stepped down and also stepped up for their fusion research not to be left behind. Soon the Soviets came up with a viable decision and design to sustain nuclear fusion, the artificial sun. In the stars such as sun, hydrogen atoms combine to produce helium in the thermonuclear reaction and release immense energy in the light and form of radiation. Ordinarily, the atoms cannot fuse. The like charges of the electron cloud surrounding the atoms would repulse and keep them at the bay from coming too close. However, in the core of the stars, the temperature is some around 15 million Kelvin. All the electrons are ripped away at these temperatures, forming what is known as plasma. Further, due to gravity, the pressure builds up 200 billion times greater than Earth's atmospheric pressure, making the density to become 150 times that of water. In that sizzling heat, with the intense pressure and dense core, the plasma of hydrogen fuse with each other to form helium, sweeping colossal energy in the form of light and heat. If only one mimic the condition of the interiors of the star, we can artificially ignite fusion. the fusion reactors which also permits us to do so at tokamaks. What is tokamak? If the fusion has to occur, the first step has to be the creation of hot plasma. Heating a tiny pellet of hydrogen to millions of degrees and also generating plasma is not that hard. Lasers could do that job as well. However, to keep the fairy plasma at millions of degrees from touching the container wall is another challenging thing. So some of the physics conceptualize that if one can create a magnetic field in the shape of a torus like a South Indian vada, then scorching plasma could be contained in the invisible magnetic bottle. The scattering of the walls of the container could be prevented. Based on this concept of theory, an experimental reactor was built and demonstrated by the Soviet team. So the tokamak is an acronym for tongue-twisting Russian term which means that toroidal chambers. Although alternate designs such as Z-pinch and also stellars have been designed and tested, but tokamaks are still the rage for achieving the fusion. The research on fusion commenced by being shrouded in the worrying secrecy of the Cold War, but the efforts to harness energy from thermonuclear fusion today, thankfully, is a global collaborative effort. 35 countries including India, Russia, United States, United Kingdom, China, European Union, and also collaborating jointly building the largest tokamak as a part of International Thermonuclear Experimental Reactor. So the idea is germinated in 1985 after ups and downs since March 2020. Energy for the 21st century. Nuclear fusion, by the process by which the sun produces heat and light, could provide an almost limitless source of energy with no damage from the greenhouse gases or acid rains. Hydrogen ion fuse at around 10 to 15 million degrees in the sun, also creating helium and releasing heat and light.